Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. This week we're going to be talking about genomics, CLIs, directed acyclic graphs, workflows, etc. And to do that, we're joined by Mike Lin in Honolulu this week. Hey Mike. Mike is an open source developer, and in fact he's the lead developer on a project called miniWDL. Which is an implementation of the WDL workflow description language.
Thanks so much, and very excited to share some work we've been doing, as you mentioned. So, I'm a kind of long time both open source developer and kind of bioinformatician in the genome informatics field. One of the things that's really exciting about that field that I've always enjoyed is it has this very collaborative open source nature, and that kind of sharing and portability, I think, has been put into very stark relief actually these last couple of years with tracking all the variants through DNA sequencing or RNA sequencing, I should say, of the coronavirus. So miniWDL is a lightweight Python implementation of the WDL language and a runtime for it. So as part of this project, we implemented a AWS batch backend for miniWDL, which brings it up to par with many other kind of bioinformatics workflow engines, including one or two others for WDL, right, that can submit jobs to AWS batch. That's great.
Yeah.
But I think the miniWDL project, we've always tried to focus on that developer experience, and so we wanted to put a kind of interesting, different twist on it, which in this case entailed embedding the new kind of miniWDL plugin and batch interface inside Amazon SageMaker Studio, which might be coming a little bit out of left field here, but SageMaker Studio comes from the AI/ML side of AWS, and it's a kind of hosted IDE environment. And you can see this domain sagemaker.aws, right? So you click through into this IDE environment from your AWS console, and it's put together in an interesting way where you have Jupyter notebooks and connectivity out to Elastic MapReduce and Batch and SageMaker. But the nice thing about how SageMaker Studio is put together is all of those different moving parts of it have a shared view of data through Amazon EFS, the kind of shared Elastic file system, which is great because it provides a kind of very familiar abstraction to those of us coming over from the scientific computing and HPC.
EFS is a good medium for that because EFS is, it's cross AZ, it's visible everywhere inside a region. You can spin up your workloads almost anywhere.
So with SageMaker Studio, I can just open up my WDL workflow source code in a code editor tab here. If I start a Jupyter notebook and I load some data files, right, those kind of look like paths that I see in my file system browser here. And then for our present purposes, SageMaker Studio even has a just bash command line terminal. That you can poke around your file system in the way that we're all used to using locally. And here indeed is where we have set up miniWDL with its AWS batch plugin. Right, so I have teed up here just a miniWDL run invocation with this WDL workflow code that I had the code editor tab right next open to it. And just giving the paths of some input files that are in this source code here, right? And saying, here's the directory I want to run it in, and some command line flags. And I just punch that, and it will start, loading the workflow, checking the input files, and submitting jobs out to AWS batch. So that will take some time here. This is running a viral genome assembly here. I won't wait for it, right, because I can see here in my file system browser, right, I just have some previous runs of this same workflow. So with the kind of cooking show trick, yeah, I can see all the artifacts of my previous, replica of the run that I just kicked off here, right? And again, all in this one kind of unified view. I can, open up the log file of that workflow. I can, look through the outputs. SageMaker Studio here is, presenting my JSON file here to me in this nice way. And then these subfolders here in this EFS file system, right, are essentially the working directories of all the AWS batch tasks, right, that started up as part of this workflow. So I can even, click into those, right, and kind of see the standard out, standard error of those tasks, look at, the stuff that was actually in the working directory. So, just to bring it back to what we're really doing, this is a DNA sequence, right, that was either the input or output of this task. So through this kind of file system browser, or again even through my terminal, right, I can just in a very familiar way keep an eye on what my workflow is doing after it's done, whether it succeeded or failed. I can look through and see what actually happened, where did things go off the rails if they did. Even the timestamps of the files tell me something. So it feels, sort of like I'm developing this workflow on my laptop, right, with my source code here. Maybe I found I goofed and I had a bug, so I can just change it here, right? Save the file, Command S, and flip back to my terminal and run it again, and iterate very quickly like that until I'm happy. So one thing, you may have noticed I didn't show so far, right, was anything in the AWS console, right?
Yeah. So I was going to ask
But
about that. How does
yeah, but
all this orchestrate, right?
yeah, but indeed, this miniWDL is just running inside SageMaker Studio here, but just launching batch jobs. So now if I go out of my way and open up the AWS batch console, right, I can see I have my job queued up, right, and some of my my prior jobs from my previous run just still recorded here.
And
So
you're saying that miniWDL does all of the, apart from doing all of the job orchestration in batch for you, it also sets up a compute environment for you in batch,
so
like the CEs in batch itself?
the compute environment is set up as part of the kind of deployment of this solution, if you
Right.
will. That is not done by miniWDL itself, but by a series of CloudFormation templates that the AWS Life Sciences team has out there called GWF Core. So this is an architecture diagram of our IDE solution, where we have miniWDL installed in SageMaker Studio with its built-in EFS file system. And then that's connected up to the AWS batch stack deployed by GWF Core, which sets up a Spot compute environment that miniWDL in this solution submits jobs to. And this the deployment of that stack is kind of part of the deployment of the integrated solution here, where in the blog post we have a reasonably short procedure using a little bit of glue code that we added using the AWS CDK to bring together to connect the various parts here between SageMaker Studio, miniWDL, and GWF Core. So that's all in the blog post here, where things take a little time to deploy, so it will take about 20-25 minutes to go through the whole process. But at the end, you have you just click and open this SageMaker Studio IDE, and you can kick off your workflows and get going quite quickly here.
Right.
And then of course have full access to the Jupyter notebooks and all the other features of SageMaker Studio, which often come in, really handy for carrying on after the batch analysis, right? To then actually, curating and integrating the results.
So the
Absolutely.
good thing here, I guess, for the uninitiated who may be watching, who haven't played with AWS Batch before, you're going to be able to use AWS Batch without having to know that you're using AWS Batch, which is perfect, right? That's removing undifferentiated heavy lifting if there ever was any. This is just one of the cool tricks that miniWDL and SageMaker Studio are doing. But the good thing here is when you're not running things in AWS Batch, it's not charging you anything because it just winds down your infrastructure pretty much automatically.
Really, what we're showing here, it really is hiding quite a lot of the complexity, as I think, as we touched on earlier. All of the different steps in these workflow, or a lot of them have, in some cases, wildly different compute requirements, right? So some of the steps are single-threaded. Others will happily use 32 or 64 threads on one node, right? And really, just with my one command there, a tremendous amount is going on under the hood with spot instance bids to save me a lot of money on that, right? And sizing the instances, that kind of right size over time to I've such and such many jobs running that are single threaded, right? And but then a few over here that need some big iron and batch handles spinning that up and down.
Every single one of those tasks is going to be a job on the cluster, and it's going to be in a queue waiting to get resources. And it's almost certain that then things like workflows are not going to feel like they're happening now. They're going to be happening in the middle of the night, and maybe they're going to be dependent on a step that could be days away from getting executed, right? So it's a difficult thing to do in an environment where you just don't have any elasticity. This is kind of just purpose built for the cloud.
Yeah, the solution we have here with the web integrated development environment, right? We've also built into the Amazon Genomics CLI, right, which really deploys a more API-driven stack, right? That is suitable for it is suitable for command line operations as well, but also has an API interface where you can really have your stacks deployed and drive either from the command line or in a automated API invocation way. So I think what we're really excited about is if this covers the production side, right, and your laptop is dev, right, I think the miniWDL SageMaker Studio solution is like the really great staging area in between, right, where you can you can debug things with the cloud resources, make sure it's dialed in, troubleshoot anything that goes wrong, right? But then, ultimately, when it's really ready to be run in a fully automated way, day in, day out, right? Then, we put the pieces together in a different way.
And with that said, if anybody else out there wants to see us cover other topics in the future, deeper dives on miniWDL perhaps, or more use cases, or SageMaker Studio, or anything else related to HPC, drop us a line on Twitter. Our DMs are open. Mike, thank you for coming. I think we're going to see you back here again pretty soon to talk about some more stuff. I can just feel it.
That sounds like fun. Thanks for having me.